So this is data analytics fundamentals, and we are starting today. So this is going to be the first session, and my name is Raghu. I will talk about myself a little bit. Don't worry. Some of you might know me, and I may be new to some of you, right? So before we even start, this course, like I said, is something very special. It's not like a regular course that we do. And I know that the logistics for the course comes up later. But what I want all of you to do is quickly grab a pen and paper or pen and book, because you will be doing something in this course. I mean, like, you may not be sitting idle. You may have to write something, do something. So I'll give you probably a couple of minutes for that, but please grab a pen and a paper or a book so you can write something, right? So this is something else. We have included certain activities, and we really would love all of you to participate in those activities. And for those activities, you will need a pen and a paper, right? So so usually we talk about the logistics later, I mean, after a couple of slides. But I thought I will give you some time to grab this. So okay, so let me talk a little bit about myself. You may probably figure out that I look a bit older than from my picture. So there are certain reasons for that. Probably I'll talk about it later, but this is my real picture. What you see here is not real me. It's me, but I don't know, right? So to talk a little bit about myself, I have around 16 years of industry experience, and primarily what I do is I work with data. So a lot of people ask me, like, hey, what do you do? Like, what is your job? So over the period of time, there were like different roles, different positions. But after a certain time, you really understand what you do. So now I usually tell people that, okay, I work with data. That's it. I just work with data, right? Data is my bread and butter. What I do with data is a different question. I mean, there are a lot of tools and technologies that we use, but end of the day, what I try to do is get the data, make some sense from the data, and help people to use that data. That's basically what I do. But if you really want a technical introduction about myself, for the last 10 to 12 years, I have been working in the area of big data analytics. So big data is this area where you handle huge amount of data and then analyze it and then make predictions and insights from the data. So my primary expertise is actually big data analytics, and there are a lot of tools and technologies that we use in that. And I was fortunate enough to work with a lot of MNCs, including Cisco. I have worked with Microsoft. If you talk about Flipkart, if you talk about Uber, I was a consultant for them. So I was fortunate enough to work with a large variety of companies from the industry as a consultant. Even in the banking sector, I have worked. So, and that's about me. I think we should speak less about me and more about the course, right? So, and if you really talk about the technical expertise of me, like I said, the primary expertise is actually big data. On top of that, I also work on cloud. So basically, AWS, Microsoft Azure, Google Cloud. I work on all these platforms, and probably a little bit of machine learning and AI. I seriously think about this, right? You cannot live without AI. AI is everywhere. So I also work a little bit on the machine learning and artificial intelligence side. All those things has one thing at the center, which is data, right? So that's what I simply said. I just work with data. That's more easy to convince people, right? Anyway, that's my introduction, not something very important. And this is our learning journey for today, right? The TOC, or the table of contents. Before we jump into this TOC, I have one more thing to discuss about this course, because this course says data analytics fundamentals. So when the first time when we were discussing about this course, I was like, what? You want to do a fundamentals course on data analytics? Who will do that? And then I realized nobody has done this before. I mean, it's a surprise, right? So when you hear the term data analytics, what is that comes to your mind, right? A lot of tools and technologies and cloud and this and that and all these things, right? Or probably Microsoft Excel, a lot of tools basically. So the interesting fact is that there are a lot of courses in the market where you actually teach a tool. For example, if you want to master Excel, there are millions of courses to learn Excel. Yeah, I mean, you can find it anywhere you want. Or you want to master Tableau, Power BI, Hadoop, databases, there are like millions of courses out there. So what we figured out is that a lot of courses are there which teach you the tool, but there are zero courses which teach you what you should be looking in these tools. For example, I may learn Excel, right? I will learn Excel today. Probably I'll take 2 months to learn Excel. I know all the shortcuts. I know macros. I can literally create everything in Excel. But end of the day, why am I doing this? I mean, if I get a job and if somebody gives me some data, what will I do with it? I know all the charts, all the formula, everything, but is there some sort of like a ground for all this? That's what we are doing here. So it's very important to set the expectation for this course, because this course is very unique. It's nothing that we have done before. I mean, it's like very fresh, very new. And if you look in the industry, I have not seen this course anywhere. You can probably check it out, because this course is talking about what do you want to do with data. It's not talking about a tool. For example, we are not doing hands-on with Excel, calculating top 10 revenue, calculating the profit. No, 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 no. Stop, stop, stop. We are really asking the question, why are you doing this? If I give you a tool, if I give you some data, how do you make sense from the data? What are the ground rules to approach this problem? That's what we are addressing in data analytics fundamentals. So like I said, it is a very unique course, and I'm quite sure that it will give you a perspective, a fresh perspective to look at the data, right? And then once you understand how to make sense from the data, you can use any tool, it doesn't matter. Just to give you an idea, when I started my career, I was using Microsoft Excel, okay, to do the basic data analytics. Microsoft Excel is what? Probably it will cost you, I don't know, 1,000 rupees per month, right? Today, I mean, I don't know, somewhere around 1,000 rupees. After 5 years or 6 years, I was using Apache Hadoop, which cost $1 million. I mean, look at the difference, right? 1,000 and 1 million. But the same kind of analytics I can do using both. Of course, the size of the data may vary, but I can use Excel and Hadoop to draw the same conclusions from the data. But to do that, I should know what I'm looking for. So this is very interesting. It's like a detective story, yeah, I don't know if you love this, but I really love Sherlock Holmes and Watson, Arthur Conan Doyle. And there is a series about them, right? And BBC has done a Sherlock series. So this is more or less like that. Okay, I'll give you some clues, some evidences, some data. What is your inference? Yeah, so let's get on with it. So that's the idea why we are doing this course, and this is session 1. And I think I did my introduction, that's fine. And in this particular session, this is our roadmap of the content, right? So we start with data analytics introduction, its importance, and the origin, right? Then we talk about the role of a data analyst. We'll get into that. And then we have some very interesting real life case studies. For example, one of them is related to IPL, and one of them is related to the most rated TV show in the history of mankind. I mean, I don't know if you watch TV shows or series, which is the highest rated series that you know. Yeah, so a small example on that. Then we speak about types of data analytics, where there is descriptive, diagnostic, predictive, and prescriptive analysis. So we'll get into these terms. So right now you may be thinking, hey, this guy just started the course and he's throwing a lot of jargons at me. I don't even understand what he's saying. Don't worry, this is just the roadmap that we have. All right, so these are the points to remember. I think some of them I already explained. First of all, take notes if you want and use a pen and paper. I want all of you to have a pen, pencil, paper, whatever you want, just to do some activities. So we want this session to be interactive, so make sure to answer any questions asked by the mentor. Oh, I'm going to ask questions. Not like that, and I just want like the session to be interactive. Now, usually we start with a slide, but I'm not going to do that, right? So in every class, it's like the first slide, what is this, what is that? I'm not going to do that. I'm going to give you probably 4 minutes to do an activity. I mean, you have to do it, then I will help you out. So what is this activity all about? Uh, this activity is planning the perfect weekend. So what I want you to do is take your pen and paper, and I want you to plan a perfect weekend. A weekend, let's take Sunday. So today is what? Thursday, right? Okay. So this Sunday, how do you want to spend your time? What are the things that you are planning to do? And how effective can you do them? What about the money, right? I mean, it's not like I want to see Burj Khalifa this weekend. I can definitely see Burj Khalifa, but that'll be like too costly. I have to fly to Dubai, right? Probably I can do that, but the money is there. But instead of that, probably I'll watch a movie, then go out with my friends. I don't know, right? So just be honest with yourself. You don't have to show me the answer like, okay, this is what I'm picking my girlfriend and going here. You don't have to do that, but just spend 3 to 4 minutes and write down how a perfect Sunday will be for you. And this is important as an activity. So I'm going to give you like 4 minutes to do it starting now. Pick up your pen and paper and try to do it. If you're really adamant, like, okay, I'm not going to use a pen and paper, then you can plan this in your mind. But I really love if you use a pen and paper. Yeah. So let's see how many of you can plan a perfect weekend. Yeah. Let's see. See, if I ask you for a perfect weekend, you may just say that, okay, I'll go to a movie or something like that. But let's break down this process, right? And just be with me. So the first step that I'm going to do is define the question, right? So define in the sense like when I say a perfect weekend, what does it mean to you? Is it like I'll go for a movie? Not everybody likes a movie. Is it like I go out with my friends? Or is it like I sit and watch, probably binge watch an entire series at home? I don't know. So the first thing is that we define what we want. So let's say we are a movie buff and we plan to watch a movie. Okay, so that's one thing that I definitely want to do. And the second thing is that, okay, after the movie, I want to take a short break, maybe go home. And then in the evening, probably I want to hang out with my friends. So this is my primary idea. But at the same time, what I also do is I consider other options. So the second step that we normally do is collect the data. So if I want to watch a movie, probably it's a nice idea to watch Mission Impossible, right? So that's in theaters now. So I start collecting the data. Okay, what are the movies and where are they playing? How much is the ticket cost? And if I cannot make to a movie, what are the other options I have? So probably I will rate them. You know, watching Mission Impossible in IMAX will be 10 for me because I'm a die-hard Tom Cruise fan, right? Maybe something else. It may be age, maybe having breakfast or roaming around the city, visiting a garden. So I pick up all of them and I label them and I say that, okay, this is what I really want to do, but these are the other options. So gathering data is really important about what you want to do. The third step that I might probably consider is clean the data. When I say clean the data, I may have a lot of unwanted information, right? For example, I go to book my show or some place and look at all the, you know, theaters where Mission Impossible is there. And maybe there are like 100 theaters. I just want to get rid of all this clutter. I concentrate on probably 2, 3 theaters, which are my nearby. Same goes with visiting a garden or whatever you want. So step number 3 is that you clean your data or whatever you have. And step number 4 is analyze it. So this is where I look at my list and I really want to make a decision. For example, I may want to watch Mission Impossible, but then I realized like if I go to IMAX, it's probably too costly. I can go to a regular Dolby Atmos theater that may be a little bit less. And anyway, Mission Impossible is not shot on IMAX. It doesn't make any difference, right? So I may weigh all my options, analyze it, and then I may decide that, okay, this is where I want to go. So that is step number 4. Step number 5 is visualize the results. Now, this can be done with the help of a tool for a complex problem, or this can be done in your mind if it is something small. What you basically do is that you take a pen and paper, and then you write down everything, and then you plan your day. For example, you say that, okay, 9 o'clock, I wake up, and 10 o'clock, I'm out, 11 o'clock, I'm in. So you basically visualize what you want to do. Now you may be thinking, hey, for a simple weekend, why are you writing all this down? I mean, what difference does it make? You see the difference. Previously, most of you told me that I'll just go watch a movie or something like that. And that was very vague. Now you break down that same process into different steps. So you get more options to compare. And also now you are more certain about what you really want to do. So why I'm picking up this example is to demonstrate that data analytics is not some high tech, supercomputer thing. It is something that we apply to our daily lives. So this is a classic example for data analytics to plan a weekend. You may be thinking planning a weekend has nothing to do with data analytics, but if you really apply these rules and write it down, I mean, think about it, right? You may just want to go out for a weekend, but what if you have 10 friends or 20 friends? Everybody will have a different opinion, right? So rather than just fighting with them, if you just lay out like this, then a decision can be made very easy, right? For example, somebody may suggest I'll go to this movie, this location. You can actually compare and say that, hey, this is going to be less cheaper. Or you can say that this to this time we are free, so we can probably use it for something else, right? So data analytics basically is a part of our lives. It's like gravity, not exactly like gravity, but see, gravity is something which is acting everywhere, but you really don't believe it, right? I mean, you believe it, but if I drop a glass, it hits the floor because of gravity. But I don't think like, okay, gravity is pulling the glass, right? But gravity is everywhere. Same like that, data analytics is part of everyday life. Even people who have never seen a computer apply data analytics on daily lives. So this is the most important point. I see in a lot of interviews, I mean, these days. So I tend to be in the panel of a lot of companies for interviews. And in a lot of interviews, the interviewer will be asking these kind of questions. Given a problem, how do you break it down? So this was just a sample dose for you. I mean, if you were sitting in an interview and the interviewer asked, how do you define a perfect weekend? What will be your answer? I'm quite sure all of you answered really well, but what the interviewer might be really looking for is a step-by-step drill down approach that we created. So that's why this is important. So kudos to all of you. I mean, there is no right or wrong in this. I just wanted to do a small activity before we jump into the slides. And this is the introduction to data analytics. So if you look at a definition of data analytics, it says data analytics is the science of analyzing raw data to make conclusions about that information. It involves using various tools and methods to identify patterns, trends, and relationships within the data that can help organizations make informed decisions and improve their business operations. Now, honestly speaking, this looks like a Wikipedia definition to me, right? So we have to have some definition, right? So this definitely looks like a definition, but I don't want you to like, okay, by heart a definition or mug up a definition. So let's understand what this definition is all about. So the first thing that it talks about is it is a science of analyzing raw data to make conclusions about that information. Now I'll give you a simple example. Let's say you have a piggy bank and you're collecting money. Not now, but let's say you are a kid and you're collecting money, right? Now I have a 8-year-old daughter, 9-year-old actually, and she has a piggy bank. She collects everything in that piggy bank, coins and notes and everything. And when I look at her, sometimes she breaks the piggy bank, opens the piggy bank, and says that, okay, you know what? I have more coins than the currency notes. And sometimes she says that, you know what? Last month was the month when I got more amount of money. And sometimes she says, okay, dad, you're not giving any money for last 2 months. That's perfectly data analytics. So it's basically deducing something from raw data. So the piggy bank is an example for raw data. It has just coins and currency notes. But from that, you can identify trends and patterns and everything, right? For example, my daughter identified that last 2 months I was not giving any pocket money from the piggy bank. So she was actually making sense from how much she is saving, and also that's but basically what you mean by identifying patterns, trends, and relationships, right? And why do we really do this? So that we can improve the business. Now, end of the day, the goal of every organization is to improve the business, right? So if you take this into a different example, one of the example that comes to my mind is McDonald's. You see, McDonald's is a very large food chain, right? So they have like thousands and thousands of outlet, right? Especially in the US, they have thousands of outlets. So what McDonald's does is that they collect the sales data from all these outlets, right? So they collect the data first. That's the raw data. For example, today we sold 1,000 burgers, something like that. Then what they do, they also collect the weather data. What was the temperature? What was the humidity? Then they do a comparison to identify trends. For example, I don't know how many of you know this. I really love the ice cream in McDonald's. Oh my God. I mean, that small ice cream, what you call cone, right? I mean, it's like very cheap and very nice. So McDonald's can actually figure out which are the days of the month, or which are the months in which soft drinks and ice cream sales are high, right? Or which are the months in which burger sales are high. So this will help them to adjust their operations. For example, if McDonald's already know that in the month of March, people are going to buy more ice creams and soft drinks, they can prepare their employees for that. They can tell their employees that, okay, you know what? You are going to get a lot of orders for them. So basically, data analytics is a science where you convert raw data into some sort of relations and trends so that organizations can make money. End of the day, they can make money. I mean, yeah. So end of the day, I mean, I always This is a very funny thing, actually. I mean, the end goal of all this is like companies make money. I mean, yeah, we say operational expenditure has decreased or whatever, but they make money. Yeah, but that's why we are here, right? I mean, otherwise there is no point. Anyway, so that's data analytics introduction. And why is it so important, right? So like the last part of the last slide, right? Okay, we collect the raw data, we make some inferences, but then why are you doing it, right? So the first point is data driven decision making. Like the McDonald's example, all your decision can be made using data. Second is enhancing customer experience. Now, there is a very interesting example for this. Walmart, right? Walmart. So, I mean, I always give this as a very interesting example because when we think about data, we always think about, numbers and, Excel sheets and tables and database and all, right? But there are other type of data as well. So, for example, in Walmart, what they do is they have these cameras everywhere. Okay. And when you walk into a Walmart store, you will be recorded, you will be tracked. And why are they doing it? So, what Walmart basically does is that they try to analyze what people are trying to pick up. For example, let's assume that there is a Walmart store in Albuquerque. Does that sound a does that ring a bell? Albuquerque. We are coming to Albuquerque in a moment. Okay, so let's say there is a Walmart store in Albuquerque and a lot of people are visiting the store. So probably most of the people are buying vegetables. We don't know, right? So what Walmart basically does is that they track these people and they realize how much time they are taking to reach an aisle. For example, vegetables may be way back. That means the customer has to walk a lot to reach there, right? So if they analyze this data, I mean the video data, they can figure out which are the items most frequently picked up by customers. And then they can rearrange their shelves so that the customer experience is improved. So if I'm a Walmart customer, maybe I also buy a lot of vegetables. Next time when I visit, the vegetables aisle is in front of me. So I will think, okay, nice. I mean, I don't have to walk all this way. And I don't know if you have visited a Walmart store, it's like really huge. You will practically get lost inside one, right? So that's an example for customer experience where they use a combination of video footage and artificial intelligence to rearrange their shelves. Increasing operational efficiency. Again, a lot of companies, what they do is by looking at the sale of the product, they can, control their logistics. For example, there is Pepsi and Coca-Cola, right? And some people like Pepsi, some people like Coca-Cola. What do you like? I like Coca-Cola for some reason. So Pepsi and Coca-Cola, they're like huge companies, right? I think both are under one umbrella. I don't know, whatever it is, right? So if you can figure out what people like in one particular area, then your logistics can be adjusted. For example, I know in this city, people are going to consume more Pepsi. So there is no point in unnecessarily shipping a truck of Coca-Cola. I mean, people love Pepsi anyway, right, in that city. So that's operational efficiency and predicting trends and market changes. So I'll come to this predicting trends later. I mean, prediction is a difficult word to talk about. I'll come to that. Mitigating risks and frauds, especially in the banking. If you look at the banking, right, I don't know if you have ever noticed this, right? You can try this if you want. I mean, don't try, but if you want, you can try, right? If you have a credit card, for example, right? And if you swipe your credit card for a bigger amount, immediately a customer care agent will call you. Have you ever experienced it? I have done that. For example, let's say I have a credit card and the limit is 5 lakh rupees. I swipe for 4 lakh for some reason. Immediately they will call. I mean, I have experienced it many times. The second example will be the same credit card if I use for an international transaction like euros or US dollars, immediately they will call. Why? So that is mitigating risk and fraud. All these credit card companies and banks constantly do data analytics to figure out fraud. So, I mean, what are the chance I'll swipe for 4 lakh rupees? Very rare, right? Unless I don't know, something. I mean, very rare, right? So if there is a transaction of 4 lakh rupees, right, there is a chance it is a fraud. And to understand that, you have to analyze the previous data, data analytics, right? You have to analyze all the data to come up with this. And personalization and targeted marketing. So that's basically like giving you customized offers and all, right? Say, for example, you buy stuff from Amazon. Or let's take a different example. You listen to songs from Spotify a lot, right? So you know that if you keep on listening to Spotify, they give you personalized recommendation, right? If you're a premium user of Spotify, the recommendations are even better because you're paying money, right? And they want to retain. So how do they do this? How do they give you personalized recommendation? That's with the help of machine learning, but end of the day, that's part of data analytics. So today, I cannot think about any business which does not involve in data analytics. Every business does this. Now there is an interesting slide. I mean, doesn't mean like the other slides are not interesting, but see, um, if you think about data analytics, so I asked this question to many people like, okay, when do you think all this started? Like the data analytics, right? Uh, so can you take a guess like when did data analytics actually started? I'll give you like 30 seconds. You can say like 1980, 1940, 1900, I don't know, any year. When did data analytics actually start? What do you think? It started in the Paleolithic era. That's like 1 million year before. Can you imagine? You thought it started with computers, right? You are absolutely wrong. Even I thought like that. So one of the early signs of data analytics, so we call it, is the Ishango bonds in the Paleolithic era. You can actually Google this, right? So this was like a earlier form of calculator. So, and these were used by very primitive people. Like, imagine 1 million years ago, how was people, right? I mean, like very primitive, but even they had analytics in their brains. So I think it is more or less passed by the genes and, all. I mean, it was already there. So the first glimpses or the first evidence for data analytics is actually from Paleolithic era. Then if you look at ancient Egypt and ancient Sumeria, that's like 3000 BC, they were very good at data analytics. For example, in Egypt, they were doing regular census and statistics. Yeah, even statistics dates back to 3000 BC, right? And you know this pyramids in Egypt, right? And pyramids were built using humans, we believe. We really don't know how they were built, but it took a lot of efforts to build pyramids. So in early days in Egypt, they were using stats and census to allocate workforce for building pyramids. Data analytics in the mummy returns, right? I mean, yeah, so Egypt was there, and then Sumeria, right? So ancient Sumeria, they had clay tablets as databases, right? I mean, when I say database, what does come to your mind? I mean, Microsoft SQL, and people are like, oh, okay, I know all this. But 3000 BC, people had databases, not like what we see today, but of course, right, scribbles and then tables. But ancient Sumerians were very good at tables and correlations. But now we have to come to the present day, right? In the 19th century, one of the early examples for data analytics was actually Henry Ford, the person behind Ford Motors. And he was using data analytics to optimize the assembly line, car assembly line. And in 1940s, government started using computers for predictive analysis in many government areas. And in 1960s, we started using something called decision support systems, or DSS. So basically, DSS is like large computers, but they are more into predicting like what is going to happen, right? So you don't have to buy hard this. It's not like if somebody going to ask you like what was the thing they were using in 1960. This is just like a timeline. Now, if you look at today, what's happening? So in the late 20th century, big data came. That's my area, obviously. So big data, like I said, is huge amount of data. I mean, if I ask you what is the size of data, you normally say gigabytes, you will say terabytes. But then if you go beyond, there is like petabyte, exabyte. So 1,000 terabyte is petabyte, 1,000 petabyte is exabyte. So when you have raw data in these volumes, how do you make sense? How do you do analytics? That's where big data comes into picture. And after that, in the early 21st century, it became very critical, right? And then the emergence of AI in data analytics. So the latest trend, I should say, is AI, or artificial intelligence. And you will hear a lot of terms related to data. And unfortunately, I may not be able to clarify all of them because they are beyond the scope of this course. For example, there is data fabric, data mesh, data lake, data warehouse, so many things, right? But all of them represent taming the data, storing the data, and making sense in one or the other way. That's basically what it is. So we are in 2023, and now data is a complete different ball game. Data remains the same, but now we have the power of computers, and it is like increasingly ever now we have the power of computers, and we have the help of machine learning and AI to do data analytics. I'll speak briefly about this later, like machine learning and AI. But yeah, so that's something that I want to talk about. What does a data analyst do? So remember we took that example of what you call the planning a perfect weekend, right? So those are the steps typically involved in any data analytics area, right? For example, broadly, if you look, we first define what we want to do, the problem, which is very important. Then we collect the data in various forms. I'll talk about it. Then we clean the data, we remove unwanted data, so on and so forth. And then we actually analyze it, and then we visualize. But if you look at a data analyst, let's say you are a data analyst, these are some of the things that he does. First of all, you are responsible for data quality and integrity, right? So data quality is a very important thing. For example, you may be collecting data from a lot of sources. How do you know if the data is correct? What if you are getting the wrong data? How do you understand it, right? So having the quality of data is very important. A simple example for this is I have a lot of experience working with sensors, the temperature sensor, atmospheric pressure sensor. So a lot of sensors are there. So what happens when these sensors become faulty? So when you collect data from sensors, what happens? They will give you the reading. So let's say you are collecting temperature. So they will give you, okay, today the temperature was 30 degree, 29 degree, whatever. But one problem is sometimes these sensors become faulty. Like we had an experience of collecting sensor data, the temperature data basically. And normally when you collect these temperature data, you actually get the reading, right? For example, 30 degree, 25 degree, whatever it is, right? But sometimes what happens, the sensor goes bad, right? So when the sensor goes bad, it gives you a default reading. So what you get is basically like maybe 15 degrees Celsius, right? So you know that it's not correct. The actual temperature is not 15 degree. but that's the default value you are getting. So you have to ensure that, okay, the quality is there in the data, right? You need to know which data to take and which data to avoid. Basically, that's one of the rule. Then analyze and interpret complex data to provide insights. Obviously, that is the job. Create reports and visualizations to communicate findings, right? So all data analysts are familiar with visualizations in one or the other way. Um, you may probably use Excel or PowerPoint, or probably a complex tool like Power BI or Tableau to create visualizations. And this usually is charts, right? You may be familiar with bar charts and pie charts and whatnot, right? So that's one thing that data analysts are really good at. Work with various stakeholders to understand data needs. Use statistical tools and techniques to analyze the data. So the data analyst also works with stakeholders. What do you mean by that? An example will be, let's say you are working with Bharati Airtel, Airtel, right? And one of the challenge will be something what we call customer churn. So probably you figured out that last month, a lot of customers you lost. So why are you losing customers? Probably Reliance Jio came up with a new plan. You don't know, right? So you have to analyze the data and you have to come up with a reason, and you have to present it to the stakeholders. When I say stakeholders, this can be company owners, this can be the board members, because they will ask you, right? Okay, why are we losing customers, right? So a data analyst also closely works with stakeholders, right? And this is a typical process followed by a data analyst. I'll give you an example to uh, reiterate this idea. This is like just a slide. So this is the same steps that we basically followed in the planning the perfect weekend activity. So we first define the question. Like in the case of Bharati Airtel, the question will be, why are we losing customers? That's the question. You need to answer the question, why are we losing customers? Second step will be collecting the data. So first, you will be collecting data from your customers, the feedback from your customers, market data, your competitors like Geo or any other vendor. How are their plans? How many customers they got last month? That's collecting the data. Then you clean the data. You take only what you need. And now you analyze the data. You may use any tool to analyze the data, and you create a report in the form of a visualization where you say that, okay, you know what? Last month, Geo introduced plan number 1, 2, 3, and we don't have a competitive plan. So these plans offer, I don't know, games for free. Yeah. And for this reason, a lot of youngsters migrated because they love games. Maybe I'm just giving an example, right? And then you also make recommendations. You tell that, okay, how do you mitigate this situation? What is the solution, right? The solution is either reducing the plan cost or coming up with a new plan for only teenagers, something like that, right? So even though data analysis sounds very simple, the role is not very simple. Yeah, so when we say data analyst, people think, okay, so he just analyzed the data. But a data analyst role is very important in an organization, and he touches each and every aspect of the company. I'm not talking about a beginner, probably. Like if you're hired as a beginner, probably you won't do that. But once you become experienced, right, you will have your say in everything. So let's take a simple example to understand this, right? In fact, let's take two examples. Uh, One is a cricket team example, right? So let's say you are Ambani maybe not Ambani, right? Somebody, you're somebody who is really interested to pick up an IPL team. And we are not talking about the usual teams like, uh, you know, Chennai Super Kings or Mumbai Indians, because those teams are real. But let's say a fictitious team, right? So, what is that you have to do? You have to pick up the perfect cricket team, right? So, how do you pick up the perfect cricket team, right? So, you can see here there are different steps involved in this. For example, there is context, description, key elements, what's involved, and real life impact. So you can think about this like a, how do I say this? Like a framework or a set of rules to help you pick up the right team. So what is the context here? The context here is that you are an investor and you want to invest your money wisely. And the description of the problem is you want to select the best cricket team. Now, what are the key elements that will impact you? Decision making on data, the player data, understanding of constraints. So, if you look at this from our earlier example, the first step will be data collection, right? So, we collect the data about the players, their background, their previous performances. We collect data about pitches, different stadiums, competitors, all this we collect. So that is the data collection part, right? And then what we do, we clean the data and then we analyze the data. That all comes in your key elements here. And then there is what's involved, right? Making decisions on which player to include in the team based on available data and constraints. For example, you may really like a player to be included, but due to, let's say, the money constraint, you probably don't want him, right? I mean, uh, you can't just have everybody, right? On the other hand, you may probably find another player which is not who is not so uh, uh, you know uh, good at batting or bowling right now, but after carefully analyzing, you saw that he's really good, he had a great career, and with a little bit of help and coaching, you can make him play. So these kind of real life examples are there. And what could be the best example apart from MS Dhoni? I mean, Mahendra Singh Dhoni, you love him, you hate him, you cannot ignore him. That's the truth, right? I mean, I'm a huge fan of MS Dhoni. There are a lot of haters, obviously, but whether you love or hate, you can't ignore him. And Dhoni is a classic example for data analytics. Now, you may be wondering how Dhoni is an example for data analytics. I'm not saying that after a match, Dhoni sits with the laptops and runs some algorithms or anything. He does everything naturally. I mean, he's a natural player and a natural data analyst, right? Now, let's look at this from a data analytics point of view, right? What is the context here? Real life example of strategic decision making in cricket. So, what is Dhoni so good at? Strategic decision making, right? So, he always refers to previous matches and performances and then makes his decision, right? So do you remember this? Dhoni had this decision to use Joginder Sharma in 2007 T20 World Cup. Now, Joginder Sharma was a relatively unknown player, but Dhoni had done a lot of analytics. I mean, like mental math probably, and came up with this idea to actually use Joginder Sharma, and it played really well. Now, the description for our problem will be how Dhoni's strategies reflect principles of data analytics. The key elements are, like I said, understanding past data, right? So, Dhoni looks at a player and then looks at his past data and then decides whether he should be included or not included or etc. etc. The second thing that Dhoni is very good at is predicting future outcomes, right? So he knows how to shuffle batting order. And you will be amazed to see this. I mean, I have seen this hundreds of times, right? I'm not saying like every time Dhoni wins, but depending on the situation, he can predict the batting order. Sometimes he's number third, sometimes he's number fifth, even others. So predicting the outcome in Dhoni's way is probably reshuffling the batting order. Third is making data informed decisions, right? So he actually, there was an example, right? He had to promote himself in the up in the order in 2011 World Cup final, and we won, right? Do you remember the 2011 World Cup finals? And in that, he used data and he promoted himself in the batting order because he knew that he had to bat early and that contributed and we won. And continual monitoring and adjustments. So Dhoni constantly adjusts his strategies based on, the team, the conditions, everything, right? So, like I said, this is more or less like solving a murder mystery in case of a Sherlock Holmes mystery, right? You get the data, you look at the past, you try to look at the future, then you catch the thief in a mystery. But here you don't catch thief, but you make the right, predictions, right? Then what is involved, right? So historical data is involved, predicting outcomes is involved, and real life impact is successful cricket strategies leading to victories. So this is what we call a framework. Now, a framework is something that a lot of people doesn't know what it is, right? You hear the term a lot, but people really doesn't know what is a framework. A framework is a set of rules to approach something. In data analytics, the framework that we use is what you see here. So there will be a context first, that is like what you want to do, how do you want to do. There is a structure. Then there is a description. Like in our Dhoni's example, the description is like how Dhoni strategized everything. Then what are the key elements involved? Collecting the data, looking at the past, making the decisions, etc. Then what's involved, right? What are the actual steps involved? And what is the real life impact? Now, I always say this data. So a lot of people tell me that, okay, you know what, Raghu, like data is gold mine. Data is nothing. I don't believe data is gold mine. That's incorrect, actually. I know that a lot of you may not agree with me. Data is not gold mine. If you make sense from the data, then it is gold mine. So there are a lot of organizations who collect the data and they sit on top of the data and they don't know what to do. Data is there, but they don't know what to do. That doesn't make any sense, right? So that's where this framework comes into picture. If you get some data, you set all these context, description, key elements, what's involved, real life impact, and then you have a step-by-step process to approach the data, right? Now, I wanted to give you one more example, right? I mean, I don't know if this example, there's a general example for maybe data analytics, right? How many of you are fans of Breaking Bad? How many of you have seen Breaking Bad? Now, why am I talking about Breaking Bad? Because data analytics can be applied to Breaking Bad. Okay, what is the context? So let's look at the different steps here, right? The context here is you want to make a series, and the best series, that's Breaking Bad, right? And what's the description of what we want to do? The description has to do with budget. You see, when Breaking Bad started, it has 5 seasons. If you have not seen it, it's okay, right? Season one was like a, I don't know, like they were just trying. I mean, nobody was sure it'll be a hit or miss. So season one was okay. In season two, what happened? They went way out of the budget. Yeah. So there was a budget for a season, right? So let's say, for example, 1 million was the budget. They crossed 1.5 million in season 2. And then season 3 came, and the showrunner, Vince Gilligan, in an interview, he said that their biggest challenge was to keep everything within the budget. So what is your description of the problem? Is keeping the budget, right? Now, how do you keep the budget? So what are the key elements here, right? So first, what they did, they analyzed the previous data, season 2 data. So they realized that in season 2, they had 13 episodes. In season 3 also, they have 13 episodes. And they did some analysis and understood, okay, these are the areas where we spent a lot of money. And these are the episodes where we had a lot of location, so money was gone, etc., etc. Then they cleaned all those data, right? And now they needed a solution. So in season 3 of Breaking Bad, again, you cannot cut down the number of episodes. If you look at it, you have 13 episodes in season 3. But after carefully doing the analytics and comparing the budget with the previous season, they came up with what we call a bottle episode. You know what is a bottle episode? Okay, I'll tell you. There is an episode in season 3 which is called The Fly. You remember that episode, right? Fly. A fly will enter into the secret lab of Heisenberg and Jesse, and all they do is try to catch the fly. Yeah, there is nothing else in that episode. So that's called a bottle episode. A bottle episode is something where you minimize the cast, the location, everything. If you look at the Fly episode, there are only two people, Bryan Cranston and Aaron Paul, and the entire shoot is in the lab. But they did it so well that that episode became really good. Nobody understood, but they minimized the budget. The budget came down a lot only because of that particular episode. So you look at the approach, right? First, you look at the historic data, then you understand the problem, then you realize you cannot cut down the episodes. Then the solution from the analyst will be, okay, let's do a bottle episode. So one episode, we are going to shoot in one location, just two characters, cost drastically comes down. That's Breaking Bad for you. So my point is it is applicable everywhere if you look at it, right? And people often mistake these terms. There is like analytics, analysis, and analyst. I mean, yeah, so analytics, analysis, and analyst. So analytics is the systematic computation analysis of data or statistics, right? So that's what we were talking about, right? We are talking about data analytics. So the first thing is analytics. Analysis is actually different. It's different actually. So it is the process of examining data in order to understand and interpret it, right? So this is like breaking down a very complex topic into smaller parts, right? An example for analysis will be like if you look at these labs, right? Some of the labs, they will be conducting a lot of experiments. Now, these experiments as a whole may not make any sense. So they break it down into smaller part so that everybody understand it. That's analysis. An analyst is a person who actually does analysis, right? So this can be a financial analyst or a business analyst or anybody like that. So this is just like good to know information. Nobody is going to ask you like, okay, tell me the three difference between analyst, analytics, and analysis. But just these terms are a bit confusing. That's why. And this is probably the last slide we have. I know that people might be thinking, what is this? And this is really important. This is called the types of data analysis. So there are normally when you talk about the types of data analysis, we normally say there are four: descriptive, diagnostic, predictive, and prescriptive. Now, I know that sounds like very weird, but let me give you an example. Descriptive is like what happened in the past. So A retail owner might look at last quarter revenue to understand whether it is good or bad or something. That's descriptive. Descriptive analytics basically means what happened in the past, anything. Diagnostic means investigating why it happened, right? So, for example, like in my Bharati Airtel example, uh, last month we lost a lot of customers. That's descriptive. Why it happened? Because Jio introduced a new plan. That's diagnostic. Third is predictive. Predictive means what is going to happen in future. So if I am working for Bharati Airtel, I will say that, okay, if you don't do anything, you are going to lose more customers next month. That's predictive. Prescriptive analysis means your recommendation. So what do you want to do? So basically you can say that, okay, introduce a new plan or do whatever, right? So I have a very, I mean, I have an example for this from my experience. Okay. So this is like I was working with Flipkart. Okay. And when I was working with Flipkart, we did this, right? So one of the problem we had was about orders getting canceled. So a lot of customers were canceling the orders. Why? So the descriptive analytics was we did an analysis and we figured out that, okay, in the last 3 months, a lot of cancellations happened. That's descriptive, what happened. Diagnostic was like why the customers are canceling orders. Then we figured out that in the last 3 months, we changed the courier. So I think I was working with Flipkart in 2018. They had tied up with one of the courier company. So that change happened in the last 3 months. So when the courier company changed, what happened? The number of days for the delivery increased for many customers. Yeah. So basically I order something and I have to wait like 7 days. So I cancel because I'm getting better deal on Amazon. Predictive analytics was that if you keep on doing this, then you are going to lose money. Prescriptive was the solution to this, right? So we had a meeting with the courier company and they had set up last mile delivery centers. I mean, in some of the outskirts, they didn't have delivery. So what they did, they set up small warehouses and all so that the customers can easily get the packages. So you see, you can break down almost any analytics into these four categories. And that basically is the end of our uh, today's class. But let me also quickly do a recap. So we started with data analytics, remember? And there is the introduction, importance, and then origin. We spoke about all that. And then we discussed the role of a data analyst, right? And then we looked at some of the, real life applications like IPL, Dhoni example, Breaking Bad, etc. And then different types of data analytics, right? Then descriptive, diagnostic, predictive, prescriptive. That's what we discussed.